Hi, I'm Alex Alvarez and welcome to Dynamics 1. In this video we're going to be talking about the particle tool as well as the create emitter tool. And particle tool is something that allows you to sketch particles into your scene interactively as well as to create particle grids. And those particle objects can then be controlled via any kind of fields that you want to apply to them to design a pretty wide variety of effects. Also, we have the create emitter tool, which is used to create omnidirectional and volume emitters, and those also can be used to create quite a wide variety of results. And so we're going to be talking about those different tools as well as some creative uses for them with a bunch of examples that we can analyze to see how those tools can be implemented. So hope you learned something.
Alright, so we're going to start by talking about the particle tool, which is the most basic way to get particles into your scene. And once we finish talking about that, we'll get into emitters. And so particles in Maya can basically be created in about 4 different ways, actually. You have the particle tool, which allows you to manually create particles in your scene one by one. Or you have emitters, which allow you to create particles in your scene by having them come off of surfaces or be created from objects in world space. Also, you can have particles get created when one particle collides with an object, so a particle can create a particle. And then also particles can be created by using mel commands, like the emit mel command. So we're not going to really get into collisions or the emit command, but what we are going to talk about is the regular emitters and the particle tool. So for the particle tool, I'm just going to open the options. And again, what this tool allows us to do is to create particles by literally sort of drawing in the scene or sketching the particles into the scene. And so if I hit reset in here, there's a few different options. First is just asking for a name, which is optional. If you don't specify a name, it'll just get a default name, which doesn't matter. And then it gets this little attribute called conserve. It's kind of strange that they put this in here because there's so many attributes that particles have that you can edit after you've created a particle that it's bizarre that they chose this to be the one attribute you can change at this point. Conserve is for conserve momentum, and we'll use this later on because you need an example to see before you already understand what that means. But then underneath that, you'll see we have number of particles, which is set to 1. Okay? And then some things that are grayed out and unchecked. Well, just with the number of particles of 1, what that literally means is that if I go in my perspective window out here, and also we'll see that I don't have a lot of screen space right now, so I'm just going to hide the interface just so that I don't have, or just so I have as much room as possible. And so I'm just hiding everything, and maybe I'll just go and get the channel box to pop up, and maybe get the time slider to pop up. So with this done, with this tool set to 1 particle, literally what will happen is if I go in here and I just click with the left mouse button and drag, a little red dot has appeared, which you probably can't see, but if I let go and then click again and again and again and again and again, and I keep clicking, I'm literally placing individual particles down in the scene. And then I can hit enter, and then we can see I've got this particle object in the scene with these tiny particles, which are hard to see, but if I display or change the display of the particles, okay, we'll be able to see that there are particles there. Okay, and so these particles were literally created just by manually using the particle tool. And what's nice about that is then I can still go in and take these particles and slap a field on them. I can take the particles and put, let's say, a couple different fields on them. So let's say I'll also go and throw like a turbulence field on them. And if I do that, if I hit play, you can see there you go. You've got your particles that are animated and moving and are reacting to dynamic forces, but they were manually created. Okay, so let me just delete that and go back to the particle tool again. So instead of just placing particles one at a time like we just did, you also in here, where it says number of particles, can raise that so it's something higher than 1. So if I put that up to a number, let's say like 10, you then get the option for maximum radius. And if I specify, let's say, a radius of 5 units in there, and now I click once, you'll see that we're going to get several particles. But if I click drag, all that's happening is that it's dragging where the placement will be for that random bunch of 10 particles. So I can go and click, 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 hit enter, and there we can see is the particle object, okay, sitting in there in the scene, which again, they're kind of hard to see, so I'll just change the display res, and here we have some particles. So I can go and throw a turbulence field on those, and then you can see how those particles are beginning to move in the scene. So the particle tool is a very handy thing when you know exactly where the particles need to be in your scene, and you don't necessarily need them to be animated, growing, or moving into the scene. So a clear example could be something like clouds, where you just quickly need to get some clouds in your scene and you just sketch them exactly where you need them to be. So let me just go in here, delete these again, go back to the particle tool, and see what else we have. So we had number of particles with the radius, and then you have a checkbox which is sketch particles. Now remember before, when I click dragged, I was just clicking and placing where the marker or where these particles were going to be placed, okay? But I'm not really drawing. But if I go back to the particle tool and I turn on sketch particles, you now get this little sketch interval, which is kind of like a stamp. Like most 2D programs, you have like a stamp spacing. It's the same thing, but for how these particle stamps would be placed. So if I leave that at the default, and now I click drag in the scene, what you can see is that I'm literally sort of sketching particles. Okay? And by doing it in the perspective window, it's just placing the particles on the perspective grid. Okay? So you can see how they've gotten placed in the scene. And while I'm going and sketching these particles, you can make changes to the settings in here. So now I can maybe lower the radius down to 2 units and sketch, and maybe down to like 1 unit and sketch. And you can see how that line is getting thinner. And then again, hit enter to complete the operation. Okay. Once you hit enter, it'll take a couple seconds, and then again, you can see there are the particles in the scene. Okay. So again, kind of hard to see, so let's go and make a quick change to how those particles look, just so that they actually are not displaying themselves as those little dots. And so I'll just make a couple quick changes, and then there we can see are the particles. And again, slap a turbulence field, just kind of, it's kind of the most basic one to just sort of throw on those to see how they'll move around. And then here we've got these particles just dissipating into the scene that were just drawn. Okay. So back to the particle tool. Okay. Sketching particles then is clearly pretty damn useful. If I go in and make a new scene, okay, so certain examples could be like if I went in and needed to create like rings around a planet, or like a sort of like a meteor field where I was going to create a bunch of particles by sketching them and then using the instancer to replace those particles with meteors and pieces of geometry or whatever. It can be very handy. Like I could also go in here with the particle tool and maybe up the radius to about 5, click drag, maybe lower that radius down, maybe switch to the top view, because you can switch your view while you're drawing, and then I can go and maybe draw some particles. Okay. Move back and draw some more. And so that you can kind of sort of draw particles with a general idea of how they're going to look in your scene. Maybe going up the radius a little bit, okay, just to sort of fill this out a little bit and fill some more out there. And then you'll see that it'll get a little sluggish, but once you hit enter to finalize the operation, it'll get fast again. And so now we can see we're back to real time. There are the particles in the scene. And now, while they look like obviously drawn right now because I use the particle tool, a common thing to go and do then is maybe I'll go and slap a field on them. So I'll just go and create a turbulence field like I did before. Okay. And then for these particles, I'm just going to make a couple changes to a couple attributes and then throw, let's say, a vortex field on it. Okay. And then for that vortex field, I'm just going to make the magnitude a little bit stronger. Hit play. And then you can see how these particles are sort of spinning around in the scene. I'm going to up the magnitude up to, let's say, 500, just so we don't have to wait so long. And then once it gets to a certain point, I can stop, grab these particles, and then just go and say save initial state. So solver's initial state set for selected, which now means that those particles that I sketched in the scene, which looked kind of hokey because of how I drew them, now if I set this as selected, okay, at frame 1, I can then go and delete all those fields that are in the scene and now just have this particle object, okay, where this is now its default shape in the scene. And so you can see when I hit play, it's not actually moving because I deleted those fields. And then I could go and grab these particles and, like I did before, make a couple quick changes to how they look just so they look a little better. Let's say multi-point, color accumulation with, let's say, a opacity of about 0.5. And then we'll go in, let's say maybe up the radius for those particles, and then maybe just hide our display grid. And now you can see how we have this sort of like, spiral nebula galaxy looking thing real quick just by using the particle tool to get the particles in the scene. And again, if I hit play, nothing is happening. But for something like this, maybe you would just choose to go and animate it by rotating it. So I could go for, let's say, the rotate, let's say, Y attribute of this particle object, because particle objects do have transform nodes. Because you can see if I open the outliner, we've got the transform node and the shape node. And so if I just grab the transform node, go to rotate Y, and write a quick expression on it, so I can say maybe the rotate Y of this particle object equals time times 2. And so as time goes by, it just means that thing's going to spin around. Execute that expression. For those particles right now, they're all white, and so maybe I'll just go in and make a real quick change to their color just so they look a little bit more interesting. So maybe the RGB PP of these particles, let's say equals, I'm just going to go in here and make them purplish. And so I just have something on my shelf which will just go in and put a little rand function on them, on their RGB PP for their creation expression for when they're born, so that now if I go in here for the particles, I need to go in and make sure that I actually executed that. Okay. And so that's sitting in here, and then I'll go in and actually take this, and I'm going to copy it and also execute it as a runtime. And there we can see those particles with their color. And so in a very short amount of time, you have something which is pretty cool. If I hit play in here, we're going to see how it's rotating around very slowly. Grab that particle object, maybe go and say time times 7. Okay. Spin around a little quicker. Then I'll grab the camera, let's say select camera, maybe move back a little bit in the scene, set a keyframe, and then maybe sort of move by this object and set another quick key. And then there we can see we've got our little sort of galaxy flyby thing going on. So quick use of the particle tool, pretty straightforward. So the next thing though is there are some other things that we can do with the particle tool. And so I'm going to make a new scene. And now what I'm going to do is go back to the particle tool, and instead of sketching, because again we had number particles, sketch particles, and the stuff we just did, underneath that you'll then see create particle grid. And when you turn that on, it'll sort of turn off the other settings that we had been playing with. So creating a particle grid literally means that a grid of particles will be created as opposed to sort of interactively sketching. And so what I'm going to do is there's one thing that's going to be useful for that to know that I haven't talked about yet, which I'm actually going to show with the sketch particle mode, which is if I go in here and let's say sketch some particles. Okay, I'm just placing some particles down. And at a certain point you decide that you don't like where one of these individual particles are. What you can do is hit insert, which is an insert key on your keyboard, and then use the middle mouse button drag, or middle mouse button, to relocate these particles. So I can just go in middle mouse button drag. You can only do this while you are still in the particle tool creation mode. So after you've executed and hit enter, so the particles have been finalized, you will not be able to do what I'm doing right now, meaning you will not be able to move individual particles. And if you wanted to, you'd have to do it via runtime expressions. Okay. And so at this point, you can see I've relocated those, enter, and then there's the particle object, delete. So going back to the particle tool, and now going into particle grid, you'll see you've got particle spacing. Well, this is kind of saying for the grid of particles you're going to create, how many units of distance is there between those particles. Right now it's at 0.5. I'm just going to go now and create the grid. The way that you do it is you click with the left mouse button. So I'm just going to click drag, and where I let go will be the sort of lower left corner of this grid. And then I'll click again with the left mouse button and drag, and where I let go will be the upper right corner. So I've just basically placed down sort of 2 particle markers, and then you just hit enter. And what we can see is I now have a grid of particles where each of these particles are about half a unit apart. And so it's quite a few. And so a particle grid is kind of a quick way to get particles to sort of fill a large area in your scene. But obviously particles looking like this aren't necessarily that useful. So you sort of need to randomize them up with some fields and then resave the initial state for those particles. Okay. And so another thing though that can be really handy about particle grids though is to sort of understand how fields work, in the sense that you just create a grid of particles, throw a field on it, see what happens to the particles, and then you get a very clear understanding of what that field is. So if I go and create a radial field for those particles, it's very easy to see exactly what that radial field is doing on those particles based on its default setting. So that's just sort of like a little tip when you're trying to figure out what all these different fields do. Okay, and so here you can see that radial field on that grid. So, but let me delete that. Okay. And let's actually just go start with a clean scene and back to the particle tool. So with the grid, you saw we were able to make a flat grid, and I'm going to up the particle spacing to 1 unit. And so let's say, for example, you needed like a bunch of clouds, or you just needed some ground fog in a scene, some mist that's sort of rolling along on the ground. This could be a very useful thing to use for that. So that you basically click on the lower left corner, upper right corner, hit enter. You've got the particles that are in your scene that'll kind of be your ground fog, and then I can go in there and throw a turbulence field on them, a few different things. So let's say we start with a turbulence field, and I'll just make a couple quick changes to its settings. Okay. And then we'll see those particles get mixed up. And so you can see that was a little bit much, so I'm just going to go and chill out that turbulence field, lower its magnitude. We can see how they move. Okay. But then also a thing that can be useful is like if this is supposed to be ground fog, okay, you might not want them to move too much in the scene. Maybe you want to make sure that your ground fog always stays below a certain point. But the thing that's sort of handy for that is to go in first with these particles, and I'm going to lower their conserve. Okay. And once you do that, I'm going to need to go and grab that turbulence field and up its magnitude, maybe to, let's say, about 20. And now we can see how those are in the scene, sort of moving around with the turbulence. And then I'll go in, sort of play it a little bit. At this point, grab the particles, and then maybe resave their initial state. So set for selected. So now when I go back to frame 1, it no longer looks like this sort of boring grid of particles. Also for them, just so that it's easier to see them, let's go and switch their display. And so I'll just put them into, let's say, multi-point mode. So that's a little clearer. Okay. There are the particles, but my ground fog maybe shouldn't sort of go above a certain point in the scene. And so the quickest way to do that is just sort of maybe create a couple objects, which you wouldn't ever render. It's just an object that's sort of used in the scene to sort of keep your particles from drifting too far. And so these will just basically be very simple collision objects. And so I'll just grab those two surfaces, say that they can collide with the particles, or the particles collide with them. We're not going to talk about collisions too much, so I'm just going to go and set this up real quick. And then I'll just grab the particle and say they can collide with those planes. And so I did it with that one. And then also, I forgot to do it with this one. So let me say so that that one can collide. Go back to the dynamic relationships. Particles can collide with both of those planes. So that now if I go in here, I'll take the planes and I'll hide them so that they don't render. So I'm just going to go to the outliner, grab those two planes, and I'm just going to grab their shape nodes, hide the shape nodes. Okay. But the thing is that the particles will still bounce off them even though they're hidden. And so I'm also going to go in and make a quick change there. And now we can see how those particles, will bounce off or collide with those planes. So it'll just sort of be able to behave as sort of like a ground fog that's just sort of moving around, but always staying on the ground. Okay. So another example for a particle grid. And then also with that grid, you could imagine that this is smoke, that these are clouds or whatever. So an object could move through those, but those planes are keeping them locked down on the ground. So you could see that if I went in and quickly created, let's say, a sphere, I could go and scale this up, move this down here, let's say this way, okay, and then get that sphere to also be a collision object, and then set a couple keys on it, sort of moving through those particles, and then I can go back and tell those particles to be able to collide with that sphere that I just created, so that if I hit play, we'll be able to see how that's moving through there. And let's sort of move through it this way. But they're keeping sort of their height and Y because of those planes that are kind of locking them down. Okay, so another use of a particle grid. So with another new scene, one last thing that you can do with the particle tool when you use create particle grid is what we've been doing has been to be creating sort of flat grids. So you click lower left corner, upper right corner, enter, flat grid. But you can also create a cube of particles by still using the create particle grid, clicking in the perspective window for the lower left corner, left click, upper right corner, left click. But then what we do is we move to an orthographic window, either the front or the side view, hit insert, so we go into edit mode, we'll be able to see the two red dots, one here and one here, that represent those particles, the two corners. And then I'll middle mouse button drag to move one up in Y. So that if I now go back to the perspective view, we can see my one dot that I placed here, and this one up here, which I have modified or moved, again by hitting insert and moving it with the middle mouse button. So if I now hit enter, I get this. So I now have a cube of particles. So also useful for filling a large area with particles very quickly. So again, it's going to look kind of funky just off the bat. So you just go in and throw fields on it. Put a turbulence field, take that turbulence field, lower its intensity down a little bit, and then we can see how that all gets messed up a little bit, or mixed up, I should say, so that we now have these particles in the scene. And so you can see we just have this big mass of particles. So you could be sitting inside some huge swarm, you could be sitting inside a star field, you could be sitting inside all sorts of different stuff with those particles as they're created in a grid like that. And then what you do is at a certain frame, again, save initial state. And so now we go back to frame 1, and that's what our particles look like. So this was a cube of particles, and just by throwing a turbulence field on it, you can see what we now have started with. So there you have it. And finally, I said that was the last thing for the particle tool, but there's actually one more thing, which I should have mentioned, is the fact that the particle tool allows you to not only create particles on your grid, obviously in the front view, side view, perspective view, enter view that you want by sketching, like we've done. Okay. But you can also do this. I can go in my scene, and let's say I create a sphere. Scale this up a little bit. Okay. If I take this sphere and I make it live, so I'm just going to go in modeling mode, and I'm going to open up my status line. On the status line, you have this little big magnet. That's the Make Selected Object Live button, which if I click it, that sphere becomes sort of a green wireframe, automatically switches to wireframe mode. Well, what that means when something's live is that if I draw a curve, that curve will be a curve on surface, as we can see. Okay. But also, if I go in dynamics mode, and I can get rid of we'll keep the status line up for a sec, go to the particle tool. If I now sketch particles, let's say I'll give them a very small radius, and I'll just have it sketch a few, I can now sketch particles on that surface. And so you can see they're actually sort of confining themselves that way. So let's do that one more time. Particle tool, lower the radius down and the number, and now I'm just sketching these particles on that sphere. And so we can see by doing that, just by tumbling around, we'll just have this interesting pattern of particles. So it can be kind of handy to be able to go in and sort of model an object that represents kind of the shape of where the particles need to be in the scene, and then sketch the particles on that. Because at this point, I can get rid of that surface. They're not actually confined to the surface of that object. So you can see there are the particles, and then again, just so they're easier to see, let's just go and switch their display mode. And so now you can see there they are. And so if we went in and let's say grabbed an example, instead of going and playing with this too much, I'm just going to grab, let's say, this one. Okay. You can see just a simple example right there, where I just literally sketched the particles like I just did on a sphere, got rid of the sphere, and then put those particles into streak mode, put a radial field on them, whatever, and then there you go. And so you got like a sort of very interesting looking pattern in those particles, just like that. And then these particles, obviously, I can go in, take them, and do all the regular stuff to play with them. Maybe I'll just make their radius a little bigger, and then jump over to the hardware render buffer so we can kind of see what that looks like. So this big sort of explosion thing, which if I go into the render attributes and maybe turn on line smoothing with a little bit, some sort of render passes, we get a nice, very blurred out looking explosion, which has some interesting patterns going on because of how we sketch those particles. Also useful is if I go in and make another new scene, and again you need to get some clouds in your scene or whatever, you could just go and create a plane, okay, in the scene. I can take this plane and maybe up the number of patches that it has, let's say to like 25. Then I can go in modeling mode. Modeling mode, maybe jump with artisan. take Artisan and start sort of sculpting this thing. Okay. You know, just so that it's not all the same level. Okay. And then once I've done that, this surface that I've created, you can then make live and sketch particles onto, and then those particles could be used or rendered so they look like clouds and stuff. So that you've gone and sort of created a surface to represent like sort of like this voluminous mass of where the particles should be in the scene. And then I just go and take that surface, make it live, and then jump back into dynamics mode, and then go to the particle tool. With the particle tool, I'll go in, maybe up the radius a little bit with not too many particles, but a big radius. Okay, not huge, but just not so it's flat. And then I can just sort of like start clicking in here, you know, click, drag, of where these particles need to be. It's just they won't all be sitting on this sort of flat plane. They'll all be sort of have some sort of shape and mass to them. So if I hit enter, I can now go and get rid of that surface. And then I've got my particles, which I can then go in. And for clouds, you might be using sprites, you might be using software rendering, so I could go and put them into cloud mode and up their radius so they're overlapping, which is what you'd want to do if you're trying to do clouds. And this would be the object that you could then go in and do that way. And so you could see how when we get close on this, how this could kind of look like clouds. And so the reason they have this sort of nice up and down in them is just the way we created them by using the particle tool. So if I open, let's say, a scene where I did something like that, that would be, let's see, in this directory. And so a similar kind of thing, which I did. Let me just hide some of the UI. So if I go and tumble around in here, we can see I've got this scene which has all of these particles going on. So I've got this, which we'll talk about later, which is this sort of like column of particles. And then these clouds that are in the scene that were created just by sketching on a plane. Okay. And then if I just sort of grab a rendering of this, we can sort of see what that kind of looks like, if I can find it. Okay. And so there we go. And so in the sense that I've just sort of like sketched particles in the scene, made them software render with a little bit of noise on them. We can see the particles right there. Those weren't sketched, those are coming from an emitter, but all the clouds in the sky were just sketched on a plane. Okay. So a real quick particle creation, very interactive, which is sort of the key thing, is to try and get things to be done as fast as you can. So at this point, I would say that we've probably talked about the particle tool enough. Let's see. I mean, there are other examples. Let's say I go and grab, let me just minimize this for a second. Jump in here. Let me get this a little smaller. Let's get Maya back. I also have this example where I've got some rings around a planet. And so we can see if I sort of move through that, you know, it's just kind of like a sort of like Saturn-like debris field around that planet. But those particles that are around there were all created also using the particle tool, where I just sort of sketched particles in a big ring around the planet. Did it a couple times so that one of those particle objects, you know, would be kind of like a sort of a misty plasma-looking thing. Another one would be like a fine dust. Another one I used to instance some boulders and rocks and meteors and stuff onto. And so you can see, you know, what we're getting there. But those particles were created real quick just by using the particle tool. So to start talking about emitters, in dynamics mode still, when we go to the particles pull down, in here we can see that we have create emitter. And I'm going to go to the options for that. And you'll see that there's quite a bit of stuff in here. And I'm just going to close everything up just so that we get down to the sort of basics of what we can do with this tool. Because an emitter is basically a point in space which creates particles. And there's a few as far as its basic settings. And there's a lot of different things you can do as far as like sort of how the particles are created. And then from there's a lot of different things you can do with how you implement these emitters to design the effects that you need. And so when we look at the sort of dialog box to create an emitter, we basically have 5 folders in here. 2 of them, the bottom 2, have to do with volume emission, which we'll talk about later. But the top 3, the basic, distance, and then speed folders, are the ones that we're going to sort of be involved with at this point. And so looking in here at the top, what it says is emitter name, kind of like with the particle tool. You don't need to enter anything in there if you don't want to. In the sense you can always change its name later. It's just going to create a regular node in Maya, which is an emitter. Then we look at the first folder, the basic emitter attributes. And we look in here and we see that it says emitter type, Omni, we've got a pop-up, and then we've got all these different attributes that can change. Well, if I just go and say edit reset settings so that we're at the defaults, I'm going to hit create just so we can see what happens. And I'm going to open the outliner. So the outliner has popped up. And you'll see that there are two new things that have appeared in the outliner. An emitter, says emitter 1, and then a particle object, particle 1. And so emitters and particles in Maya are sort of separate things, which we kind of could start to understand by using the particle tool. Because when we use the particle tool, what was created was just a particle object. And that particle object could have fields applied to it. And that particle object had a transform node, because we saw how I animated one rotating. But it also has a shape node, which has a lot of information about the particles that are included in that particle object. So an emitter, like this emitter that we've just created, you have these two nodes, which are sort of independent objects in your scene. They're just related in the sense that this emitter, emitter 1, is emitting particles into the particle object called particle 1. But they are separate, and we'll see some interesting uses for this a little later. So if I grab emitter 1, I'm just going to go to the move manipulator, and I'm going to move this up in Y. And so what we can see in here is that I've got, if I go to, let's say, select emitters, this sort of like round object right there, and that is the emitter, which is highlighted. And I'm just going to hit play. And so what we can start to see is that particles are coming out of that emitter. And again, I was just using the default settings. And so if we go and look at the settings for the create emitter tool, go to dialog box, this emitter type was Omni, and it has a rate, which is particles per second. So it's a Omni emitter that's emitting at 100 particles per second. So you look at this, and what does Omni then mean? It's kind of like a point light, right? In the sense that particles are just going in all directions. And so you'll see I can select the emitter, okay, and I can also select the particle object. So if I want to make a change to like how many particles are there, I'd make a change, or how many particles are coming out of the emitter, you'd make a change to the emitter. But if I wanted to make a change to, let's say, how the particles look, you'd make a change to the particle object. So that's sort of how you're going to sort of use the two different things. So with this emitter, we'll also be able to tell, like let's say I go and do something like this. Take that emitter, move it over here, set a key, move it over here, set another key, and hit play. Okay. And you'll be able to see the effect there. And I'm going to take this particle object and make it a little easier to see those. Just because right now, again, they're on the TV screen, probably not that easy to see. And so there we go. So there you go. So there is sort of the general behavior you can expect to see, showing the independence of the particle object from the emitter. The emitter is just creating particles, but where they appear in the scene, from that point on, once they've been emitted, they kind of will do their own thing. Meaning that I can go and take that particle object and apply, let's say, a vortex field to them. And now hit play. And let me select that particle object and move back a little bit, and you can see what's happening as they're emitted from that emitter. So the emitter is just adding particles to a particle object, and once they are created, they'll do whatever they're supposed to do based on fields that are in the scene, or expressions that you've written, or all that kind of stuff. Okay. And so let's go and delete all this stuff, and go back to the create emitter dialog box. So emitter type Omni, like we said, is kind of like a point light. Underneath that you have rate. Okay, so we're going to sort of start making some changes to some of these things. And you'll see also in here, if I close some of these up, and again, just look at the first three folders, basic allows us to specify rate. Okay. Distance allows us to specify what's called a max distance and a min distance. Okay. And then the emission speed allows us to set a speed and a speed random. Well, those are some pretty basic settings, and let's go and use those. So I'm going to first create the emitter, hit create, and I'm not going to make any changes to those settings, because what I'm going to do is I'm just going to go in the scene, hit play, and then make changes after I've created the emitter. And so at this point I need to select the particle object and just sort of change those particles to being multi-point, just so that we can see them, so they're not quite as obscured. And just so that they look a little more interesting, I'm just going to make a quick change just so that they have some opacity. And so I'm just going to go in and say, let's say these particles are going to fade out over their lifespan, and I'm just going to go in with those particles and maybe give them a color. Okay. And for their color, I'm just going to go and write an expression. So our focus right now isn't particle stuff, so I'm just going to do this real quick. Don't worry so much about what I'm doing. And so I'm just entering a creation expression for these particles, okay, on their color. And so now that I've done that, if I hit play, okay, we can see the particles that have been created. Okay. Now all of a sudden we'll see when we look at this particle object that they don't seem to be living as long as they were before. That has nothing to do with the emitter. That has to do with the particle object. Because since I added a sort of expression to the particles, and I also added a opacity PP ramp, which is making them fade out, automatically a lifespan attribute was added to the particles. So that's emitter independent. But if I grab the particles, I'm just going to go in and make them live a little longer by just going to the particle node's lifespan. And so I'm going to say maybe they have a lifespan of about 4 seconds. And if I hit play, I can see how much longer they're going to live. Okay. And so maybe a little longer. So now I can go back to the emitter, okay, and take a look at this and see what happens when I make changes to it. So I'm going to look in the channel box now. And when you have an emitter selected, you're going to see there's a whole bunch of attributes that are going to be visible in there. And as you should know about the channel box shows attributes of a selected node which are keyable. So that's what defines what pops up in the channel box. And so we look in here, and we'll see all of our regular sort of transform node attributes, like translate, rotate, and scale. And we've already seen what happens when we animate the translation of the emitter. Then in here, you'll see you have emitter type. Well, right now it's set to omni. Okay. I can go and make a change to that. But before we change the type, let's move on to a couple of the other attributes, specifically rate. Rate right now is at 100. Let's say I put it to 2. Okay. Now you can see we have very few particles. So that's kind of a no-brainer of what that does. So that's how many particles you get per second. So if I put this up to 500, we're going to have a much denser amount of particles, okay, which can obviously be rendered to look a lot more interesting or a lot more feathered than the few amount, just because once you render these hardware rendered particles, you can put things like motion blur and render passes on them. So the more particles you have, the smoother and more blurred it can look. So that was just by changing the rate. Okay. So rate is something that obviously can be keyed. If I go and switch to stepped keyframes, grab the rate, put it to 0, set a key at frame 0, go to frame 32, put the rate up to 500, set another key, go to frame, let's say 39, put that to 0, set a key, and hit play, what we're going to see is kind of a simple little explosion, just by animating the rate on that emitter. Okay. And if I go and grab the keys for the rate, I can go in and make that explosion last a little longer as far as how long those particles are added to that explosion. And so we get a little bit more of a dissipation in there. So rate is a very simple attribute which you're going to be modifying all the time. It's like the one attribute of an emitter that no matter what, you're probably going to need to change for your purposes. Okay. Underneath rate, we will then see a thing that says scale rate by OBJ. Well, if you go to the creation dialog for an emitter, you'll see what that actually is scale rate by object size, which is a checkbox. And so in here, that's something that when we look at it, it seems to be grayed out in the creation dialog box, but we look at the channel box and it's not grayed out. It's something that we can make a change to. Okay. Well, that's something that you need to understand is that with emitters, just because you're seeing all of these attributes in the channel box does not mean that they're all active right now, because it's based on what your emitter type is, which is specified right here. So since our type is omni, it's only going to use some of these attributes. But again, they'll all be highlighted. It's kind of like IK. If you have like a RP handle, it's going to show you attributes that would only be used for a spline handle, for example. So something that when you're trying to get used to this, to try and figure out which attributes you can use, is just look at the dialog box for the creation. And you can see what you can use if it's omni. We can use rate, speed, speed random, and cycle emission, which we'll talk about in a sec. So scale rate by object size, we'll talk about when we get to volume emitters. So then going underneath that, we have use rate PP. We're going to have to talk about that later. That's not used right now. A whole bunch of other stuff, but then we get to these two, which are active for an omni emitter. Min distance and max distance. Well, first thing I'm going to do is I'm just going to delete the keyframes that I put on the rate of this emitter, just so that I'm back to this, in the sense of, well, let me put the rate up to about 300, and we just have these particles coming out. Min distance and max distance is the distance from the emitter that particles are created. By default, it's set to 0 and 0, so your particles just pop up at the location of the emitter icon. But if I go in and put, let's say, max distance to 10, okay, now you can see particles are being created in the scene anywhere from 0 to 10 units from that emitter. Okay. So if I put the max distance, let's say, to 7, and put the min distance to 6, okay, and we go back, we can see how those particles are being created. Okay. And so I could go in here just by changing that min and max distance and take that particle object, maybe put its lifespan down to like half a second, let's say 0.5, maybe with a little bit of a random range on that particle object. Okay. Go in here, hit play, and you can see what we have going on as far as those particles popping up from that emitter. And then maybe for the rate, I'll put the rate up to about, let's say, let's try 3,000. Maybe put it up to 15,000. Okay. And so now with a rate of about 15,000 on that emitter, I can stop playback in here. Okay. You can see that we're just sort of getting this sort of shape that has particles just on the outside of it. Okay. And so that's something that if you sort of come back on, once it fills with enough particles after enough frames, okay, I could go in here, and then that could be something that could be rendered to be like a sun, for example, in the sense that, you know, you could get up on there, have to have the rate high enough so that it gets nice and thick, but then if I go and jump into the hardware render buffer, we can sort of see what that's going to look like once we go in and make a couple changes to how the render buffer sees that. So maybe I'll go and tell the render buffer to go in, blur that out. Now it's nice and feathered. And then you can go and add motion blur and all these different types of things to that to get a similar type of effect, so that you can have a result that looks something kind of like this. And in the sense, now this one, you know, you can do it using the emission based on distance, like we have here, or you could have a sphere emitting particles. It would kind of be the same difference. We're going to talk about surface emission later on, but this is, as far as the result that we're looking at here, is basically something that can be done using the technique I just showed. And so, but that file we're actually going to talk about a little later, the sun one. But at this point, closing this, okay, the min-max distance should be pretty clear. Now going to that emitter, I'm going to lower the rate back down to 300. Another thing that could be handy though, okay, is with that rate, is these particles are obviously sort of not living very long. But if I went in here, took the particles, and maybe put their lifespan to forever, okay, go back to frame 1, and then for the emitter, I'll have its rate maybe be like 10,000, okay, and I'll key it with stepped keyframes at frame 1, key, and then at frame, let's say 9, I'll put it down to 0, set a key. So if I hit play, we're just going to see that, right? Emit for a couple seconds and stop. But if I go in and put the max distance up to something like, let's say 500, and the min distance to like 300, and then I go and hit play, okay, what you basically can get is a quick star field. And so you can see we have these particles that have been created very far from the camera, okay. And so I can go in, and let's say instead of up that high, maybe we do the max distance to 300, min distance to, let's say, 50 units, hit play, okay, and you can see those particles that have popped up in there. And so since these are particles with a hardware render buffer, they can be motion blurred, or if they were rendered in software rendering, or these particles could be sprite rendered where all of them have, let's say, sort of images on them of nebula and galaxies and all that kind of stuff. But you can see how we now have this sort of 3D star field. And so if I went in here, I could just go and select my camera as I've done before, grab the time slider, and then sort of set a couple quick keys on that camera, sort of moving around in the scene, and then we can sort of, you know, in there I set stepped keys on the camera, so I'll switch it to spline, and then we can see our little star field that our camera is moving around in. So if we combine this with that little spiral galaxy we made earlier, you'd have a little sort of space thing going on pretty quick. So I'm going to go and make a new scene so we can continue to talk about some of those attributes on the emitters. So I'm going to create another emitter, reset, omni, create, move this up here, play. All right, there are the particles. Grab the particles and switch them to multi-point real quick so we can see them. All right, so here we go again. So at this point, Okay. If I select the emitter and look in the channel box, we should now be pretty clear on what min distance and max distance are. And so the next thing that we're allowed to change for an omni emitter is speed, okay, and speed random. Right now the speed is set to 1. And so basically meaning that those particles are moving about 1 unit per second. Okay. So obviously if you start increasing that, it'll increase the speed that the particles are moving when they're emitted. So that is a speed of 10. Okay. Something to point out though for the emitter is that you can hit the show manipulator tool, which is a hotkey is T, or hit it up here on the shelf. Now it's kind of probably hard to see, but there's a little manipulator that's popped up for this emitter, where underneath it there's a little sort of blue circle, and to the right is a little yellow diamond that says rate 100. And so I can actually click drag on that to put the rate down, let's say to 24, or up to 180. If I click on the blue circle again, now it's switched to speed. So I can lower the speed down, lower it some more, or raise it. So it really doesn't make a difference whether you use this manipulator or you make changes in the channel box. I'll put the speed down to 1 in the channel box. So either way works. But you can see that for that emitter, it's basically rate and speed, and then also the min and max distance. So you can see that the manipulator actually allows me to go and change the max distance setting so that particles would be emitted from there, let's say, to there. And now I hit play, and you can see that occurring. I tend to just use the channel box though. I don't really find those manipulators to be that useful, but that is totally up to you. So speed random is something that's then sort of like a plus or minus on what the speed is. If I put that speed back up to 10, so that these particles are moving pretty quick, the speed random is at 0, which means all of the particles are moving at the same rate. And let's go in just so the particles don't look so boring, and just go in real quick, throw a couple attributes on them, maybe a little color with a little sort of generic ramp coloring those particles over their lifespan. These particles are living for 1 second right now, which is 30 frames because I'm working at NTSC frame rate. And so at this point, let's say I go to the emitter again. So I'll select the emitter, hit play, and then go to speed random. If I put speed random up to 10, okay, what we're going to be able to see in here, although it's kind of hard, let's put the speed random to about 5, is that you'll have some particles that are moving quickly and some particles that are moving slowly. And so you kind of really need to sort of look at it really carefully to be able to tell, but that is the case. So maybe I'll put the speed random or the speed to 5 in random, and now it's kind of a little clearer. It does happen, it's just kind of hard to tell because they're all kind of moving so quick. But either way, that will change the rate at which some of your particles move. Once we move on to a directional emitter, that'll probably be a little bit more clear. So as far as omni emitters, at this point, we've kind of talked about the generic attributes that we have, okay, which is rate, speed, and speed random. Another thing that we'll see in here then is cycle emission. Cycle emission is something that is used to sort of change the randomness of how particles are emitted from the emitter. And so what I'm going to do at this point is let's go and now look at directional emitters, and then we'll talk about the cycle emission. If I go and grab this emitter, okay, that's emitting particles right now, it's omni, but you can change its type at any time. If I go and click in the channel box, you'll see that if I click on where it says omni under emitter type, I'll get a pop-up, directional, omni, surface, curve, or volume. Right now we're in omni. We cannot use surface, curve, or volume right now, or rather surface or curve, because we don't have a surface or curve in here. But I can switch to directional. And now I'll hit play, and we'll see this. So directional just means that particles, instead of being like a point light emitting from that emitter, are going to behave more like a spotlight. And so by default, that emitter is emitting particles in the X direction. So if we go to the creation dialog box and switch to directional, what we will see now, if I close up some of these folders, is that here's omni. All these things are grayed out, direction X, Y, Z, and spread. But once you switch to directional, 4 new attributes are now usable. So again, it's your direction vector, direction X, direction Y, and direction Z, and then spread. So spread could be seen like the cone angle on a spotlight, while direction is obviously what direction they're moving in the scene. So if I now go to the channel box, I can take direction X, which is sitting right here in about the middle, put that to 0, and then direction Y to 1. Now the particles are moving up in the Y direction. Then I can go to spread. Spread is at 0. It has a 0 to 1 range. If I put it to 1, we'll get a 180-degree range of motion, okay, or rather range of emission. If I put it to 0.5, okay, now you can see sort of like a 90-degree cone, okay, for that emission. So directional emitters can obviously be used for a wide range of things other than omni. Omni, you might do sort of an explosion, like a explosion in the air, explosion in space where debris needs to go in all directions. But if you were doing an explosion on the ground, okay, you might go and take that emitter, move it down to the ground, put the spread to 1 so that those particles are moving out in all directions. And then for these particles, if we were doing an explosion type thing, I clearly would need to go in, maybe make their lifespan a little longer. So maybe these particles live like 4 seconds, plus or minus 1. And then we can go in for those particles, okay, and then maybe just slap some gravity on them. So that when they're emitted, we can see that they go up and out, but then our gravity field is a little strong, so I'll just put it down to, let's say, a lower magnitude. And then I'll grab these particles, whose default color is maybe a little annoying right now, and I'll just edit that ramp. And so that instead of going through the default ramp, maybe they're born kind of bright, and then maybe at this point in their lifespan they're orange. This point in their lifespan maybe they become a dark red. Close these up, and then we can kind of see what's going on there. And then for the particles also, we might want to go in and, let's say, get these particles to have a quick opacity ramp on them. And then also for the particles, I'd say we probably want to maybe up their radius a little bit and the count, so that we can now see how that's emitting. And then you'd just, like we keyed before, you'd grab your emitter, okay, and then keyframe its rate. So I'll go and switch in here, let's say, to stepped keyframes, go back to frame 1, put the rate up to like 300, set a keyframe, maybe go to another frame, lower that down to 0, set a key, and then I can go and play that and get our quick little ground explosion, which I might want to go and have a, let's say we grab a plane, scale that up, get the scale to be something that the particles can collide with. We're not going to get into these settings at this point, but now if I go and jump into my dynamic relationship window, I can get those particles to also collide off that ground plane. And then for the emitter, I'll just grab those keys and sort of move them forward a little bit in time, so that if we now go back to frame 1 and hit play, okay, let's see it go at this point, get that rate to be 0, set a key, get those all to be stepped keys, and then you can see how those just sort of explode out from the ground. So a directional emitter versus an omni emitter, obviously they both have their purposes. Directional emitter can also be used to do anything as generic like a fountain. You could have smoke that's coming out of a smokestack that you use with a directional emitter, all sorts of different types of things. So going back in here now to the create emitter dialog box, we've seen how the direction and spread are used, but something that you should be aware of with the directionality of a direction emitter is that you can rotate that emitter to change its direction vector. And so if I go in here, we can see where they're emitting now, but I'm going to go and delete those keys. So let's say delete those keyframes at that point. And I'm going to put the spread down to, let's say, about like 0.3. Okay. And then put the rate up. Hit play. And there are those particles again. Well, if I go and, let's say, create an object in my scene like a sphere, and let's say we just sort of scale this a little bit, I'm going to go in and take that emitter, which is emitting up in Y, okay, and I'm going to parent it to that sphere. Okay. Now when I hit play, everything's still the same, but you'll see that if I grab the sphere, that emitter is parented. So if I go in and now keyframe that sphere, let's say I go to spline keys, set a key, and maybe move it down and rotate it a little bit. Okay. Set a key and maybe move it over here and rotate it. Set a key, move it up here, rotate, key, and so forth. So that little sphere is just bugging out, moving around the scene. Okay. If I go and play this, okay, you can see that the rotation of the parent of the emitter is affecting its directionality. So just because for that emitter, okay, the direction is set to Y, that only means kind of like in its local space, so that if you parent to something, you'll see that you will get that correct behavior, so that you can use a directional emitter to do something, let's say like a rocket trail. Like we could, let's say, if that's what we want to call this thing right now. So a quick performance or sort of workflow tip that is pretty important is to make that clear, that you understand that that's how they work, because that makes them a little bit more useful. And so right there you can see we've got something interesting going on. So let's see. Going back into the emitter dialog, we understand omni and we understand directional at this point. So let's sort of look at a couple examples of things that can happen with omni and directional emitters when you use them in different ways. And so if I go and let's say start opening a couple scenes, we're just going to go through a few different scenes that I've got, which I've put together, which sort of show a wide variety of stuff of how these omni and directional emitters can be used. And then we'll talk about the cycle emission attribute in a sec. So let's say I go in, you're going to have to bear with me as I find stuff, and take a look at this. When I hit play in here, what we see is some sort of simple pixie dust. And if I get close on it, you can see that we've got a sprite file. So these are particles that are rendered in sprite mode, and you have to use some expressions and stuff to get those sprites to animate and work correctly and whatever. But the point is that it's just an omni emitter, right? So this is something that you're going to use all the time, clearly for doing quite a wide range of effects. And this emitter specifically is on a motion path. It's just that motion path right now is hidden, but you can see there it is. And so omni emitters, directional emitters can be placed on motion paths, and there's nothing wrong with that at all. And that motion path obviously can be animated, it can be a soft body, all sorts of interesting things can be done. So if you needed, for example, some text, like some flying logo thing, some text thing to write itself, or have some sort of like glowing, sort of sparkling object writing the letters, you can just go and create curves in your scene, that spell out words. And I'm not going to go and actually write a word, so I'm just going to go and do that. And I can go and throw an emitter on there. And it's just sort of generic motion path stuff. So let's say we go in, create emitter, we've got an emitter, omni emitter, create, close, there it is. Shift select that curve, and then in animation mode, just jump to attach to path. Go into attach to path. If it's an omni emitter, we don't care about follow, because follow just has to do with rotations. And let's say it'll go on there for about 4 seconds, 120 frames. And then we'll go in here and hit play. And if I grab those particles, we can see those particles in the scene. Okay, those particles are living for a while right now. And let's go in, make them easier to see, like we're going to do over and over again over the duration of this, but it's just what we got to do. There they are, and you can see how that's moving along that motion path. Also, another thing to point out is that particles by default do not inherit the motion of the emitter that's creating them, which I pointed out earlier, in the sense that once particles are emitted from the emitter, they'll just sort of move with dynamics and fields from that point on and forget that they were ever created by that emitter. But if you select the particles, be aware that they have an attribute called inherit factor, which is at 0 by default. So I'm just selecting the particles and looking in the channel box. But if I go and take inherit factor and put that from 0 to 1, you can see that all of a sudden we've got a completely different result. So if I go and put it into, let's say, a value that's not quite so high, like 0.2, now you can kind of see the huge difference that can occur by just using inherit. So they're inheriting the velocity of the object that's emitting them, which can be very, very useful sometimes. Like if you were doing like a hose that was spraying water out of the end, you would want the water to inherit the velocity of the emitter that's at the end of the hose emitting the water, for example. So sometimes you need it, sometimes you don't. If you're doing a rocket that's emitting smoke out of the end, the smoke probably would inherit very little. It'd be like at 0.05 or something like that. So it inherits a little bit of the velocity, but not much. Like even that's too much at 0.05. I can go to 0.01, and then we see just a little bit of that inheriting in there. Okay? So other things, let's see, along this line, if we look at some other examples, let's say I go in here and look at this file. Okay. What I've gotten here, if I wait for Maya to wake up and just switch to a full screen mode. Okay. And right now we're dealing with sleepy Maya, so we're just waiting for it to come back to us. All right, there we go. So what we have going on right here is, again, just an omni emitter, which is on a motion path. The only thing is that it's like, a little bit more dynamic of an example, with the reason being that the motion path is this curve right here. And so you can see that I've basically got this sort of like spiral motion path. Now that's something that I'm not going to get into how you create spiraling curves like that. Just know that you use the anim sweep tool, and so which is in here somewhere. Modify animated sweep. And so the way I create curves like that is I create like a 2CV curve, which I animate in the scene, maybe using a motion path or spinning it around or whatever. And then I can select that curve, do an anim sweep, which creates a piece of geometry from that animated curve. Then I duplicate an isoparm off that NURBS piece of geometry and use that as a motion path for an emitter. And so that's what's going on in this file. And so you can see that it can look quite interesting. And if I go in here, I've got other geometry, but let's say I go and hide the curve and hide the surface and hide the lattice and hide the skeleton, which is in here, and just play it back from this point of view. Okay. And you can see that that's pretty cool looking, as far as allowing you to get some interesting motion in your emitters. But again, it's just omni. So as far as the emitter itself, it's straightforward. It's just a matter of how you animate it. And so what I've actually done in here, as far as why we had all those other things in there, is I created my curve using anim sweep, and then I put a lattice on my curve, and then that lattice was skinned to a skeleton, which is in here. And that skeleton was then animated. So you can see if I go in here and sort of select all these joints on the skeleton, that I can go in and just sort of rotate those joints, but then I can go in and rotate them. And by rotating the joints, it's going to rotate, it's deforming via bind skin the lattice, and the lattice is deforming the curve, and the emitter is moving along that curve. And so you can get some interesting stuff to go on that way. A couple other examples of omni emitters. Let's say a simple example where we just have a whole bunch of omni emitters, okay, which are animated, is in here. And so if you're just doing like, fireworks or a bunch of explosions or whatever, I've just got a whole bunch of omni emitters in the scene, and all of these omni emitters are just sort of animated moving up. And so this is something that if I go in and find my movie directory, which is right here, and get Maya back, and then get that to pop up, I've got, let's see this. So this is just sort of this file, just with blur on it. A little bit of the render passes and motion blur from the hardware render buffer. And so just sort of soft feathered results and just a whole bunch of omni emitters. Let's see. What other examples do I have? I think at this point, let's see. I think we probably want to get into talking about the cycle emission attribute at this point, just because I think that, well, actually, let me show you one more thing. Takes time to find stuff. Another omni emitter, generic little explosion. Okay, hit play, and there you go. And so basically, I've just got this little sphere that's moving down, and when it gets to a certain point, there's an emitter that's parented to it. There's also a light in the scene, and that light is animated and keyed so that its intensity goes up when the emitter's rate goes up. And so actually we can see the emitters sitting right here in the scene. So it's actually not parented to the sphere. So if we go and play back, what's going on is when that sphere reaches a certain point around frame 20, this emitter's rate jumps up, emits those particles, and there you go. Pretty straightforward. We're looking at cloud particles right now, which is why they look the way they do for software rendering. And if we look at a software render of that, let me just go and grab one of those. Okay. Here we go. And so this is software rendered, and so by software rendering it, we're able to get some interesting rendering stuff going on as opposed to hardware rendering, as far as using particle or using sampler info nodes to sort of base things on the normals of the camera so that things render themselves or light themselves interesting, so that it's more opaque at the edges, more transparent in the center of the particles, and that kind of stuff. But it's just, again, an example of an omni emitter with a little bit of an optical effect going on there when that explodes. Okay. And so in this example, the particles are just sort of getting bigger, while in this example, the particles Same exact thing, I just have the particles get smaller when they die instead of getting bigger. And it's just a different look depending on what you need. And let's see what other stuff. I would say at this point, well, this one also has got a omni emitter on a motion path. Okay. And then omni emitter inside there when that thing blows up. And so when it gets to a certain point, right there, omni emitter creates that gas. Little gas that comes out of that little cracking ball. Okay? And then just omni emitter motion path stuff. And let's see. I think at this point what we want to do is start talking about the cycle emission attribute, which I've said I was going to do a few times, and now we're going to do it. So what the cycle emission attribute is, it has to do with doing stuff for games. It basically allows you to cycle the emission of particles from an emitter, because the way that it works by default is if I go in dynamics mode and I say create emitter, directional, rate 100, we'll give it a little bit of a spread. So let's say a spread of about 0.5 in the Y direction, okay, and hit create and hit play. And I'm just going to move this emitter up a little bit. Okay, so there we have it, some simple emission. Then I'm going to go in, I'm going to grab these particles, and I'm going to throw some turbulence on them. And the turbulence, let me just go in and lower that, its magnitude. So we can see the turbulence in the scene. And then I'm going to go in for these particles, and I'm also going to create a radial field for them. And so select them, radial. I'm just going to move this radial field up here. I'm going to give it a negative magnitude and a max distance of about 10. So it's just sort of attracting the particles. I'm going to get its magnitude, let's see, -2. And then for my particles, I'm going to change their lifespan so they don't live very long. And so I'm going to get them to live maybe about 1 second. Let's see how long that gets them to stick around for. Let's say 2 seconds. So that's all right. Say 1.5. All right. And then I'm going to go in and switch them to being multi-point. And I'm going to change, for those particles, the radius a little bit. Okay. So right now we've got this little particle thing and the thing going on. And this could be something that could be like a candle flame or whatever eventually once we do some things to change color and whatnot. And so let's grab the particles, opacity, get them to fade out, putting a ramp on the opacity PP. Color, I'll go in and put a ramp on their color, create ramp, edit ramp. Gonna need to change some colors in here. And so I'm just gonna get it so that maybe they're born that color, and we're just gonna have this bluish particle example. And then for those particles, I'm gonna go and turn on color accumulation and up the count a little bit. Okay. So now we can see this sort of like maybe flame looking thing or whatever, emitted from a directional emitter. Well, if I select the emitter, you will see that you've got cycle emission, which is at none right now. Okay. And if I go to the attribute editor for the emitter, you will also see all of its attributes pop up in here, which I haven't really done so far. But you can see all of the emitter attributes. And right now I'm just looking at the basic emitter attributes tab or folder. And so cycle emission is set to none. And then in there it says time random off. The reason that it says time random off is for Power Animator users, because Power Animator had an attribute like this that was called time random. And for Maya, they wanted to call it cycle emission, so whatever, same thing. So cycle emission is at none right now. What that means is that every frame, this emitter is emitting particles in a random way, a random distribution. So it's got a rate of 100 particles per second, but at every frame, those particles kind of pop up in different places as they're born from the emitter. But by turning cycle emission from none to on, or to frame, okay, when I hit play, things will look kind of similar in here at this point. But the thing that you have to understand is that there's something going on that is very different, which is the fact that what I'm going to do to make it a little clearer is I'm going to lower the rate down. The rate's at 100. I'm going to put it to, let's say, about 10. Okay. And then for those particles, what I'm going to need to do to make this clearer as well is I'm going to need to take those particles and lower that radius. Okay. so that we're just seeing our little stream of particles right there. Okay, and they should be pretty clear. Let me make them a little bit brighter. So those should be pretty easy to see. So now going back to the emitter and hitting play. The rate's at 10. Now I'm going to put the rate to 50. And all of a sudden when I put the rate up, we see these two distinct lines of particles. So this is with cycle emission at frame. And now I'm going to put it back to the default, which was none. Okay? So when it's at none, you get this random distribution of your particles, right? So your particles are sort of just popping up in this random way. And then we go again and put that to frame, and this happens. You get these streams. Now the rate is at 50. Let's say I put the rate to 10. We got one stream. Put it to 50. Two streams. Put it to 100. Okay? About 4 individual streams in there. So now this isn't a game-specific thing in the sense of the fact that you turn cycle emission from none to frame and you get these streams, but it can be useful for a variety of things. So it's not game-specific. You could use it for different effects. Okay? So for example, if I got to stop closing my QuickTime window. Go in here, and now I'm just going to minimize that. And we look at this file. Okay. This is an example of something that I did by putting cycle emission to frame and then increasing the rate so that I get these distinct little streams, and then each one of those, for the particles that are being emitted from that emitter, I just have their size go down because these are sort of blobby particles that have glow on, and over their lifespan they go from big to small. And so I got this little like sort of flame flower type of thing where it's just sort of like got these individual flames coming out. But it's by turning cycle emission to frame that I was able to get this kind of cool result. So it's not a game thing, it's just an effect thing that can be kind of neat. And so we can sort of see that going on in here. So if I switched this from a directional emitter and we switched to an omni emitter, okay, we're going to see how it's sort of trying to put them in all directions. And I could go and actually get rid of that field that I put up here, that radial field, hit play, okay, and then we can see how those are sort of popping up. And then grab this emitter and get its directionality just to be sort of 0, so it's emitting sort of in all directions. Okay. And then also I just need to go and jump in my outliner, and I'm just going to get rid of all the fields and take this and get everything to just sort of be the defaults. Okay. And so we can see with an omni emitter, okay, and then for those particles, I'm going to up their lifespan. So let's go lifespan 5 seconds. Now they're going to live a little longer. Okay. And then go back to the emitter. Okay. So with cycle emission off, the higher your rate is, basically the more of those sort of streamers you're going to get. Okay, so you can see how those are popping up in the scene. Cycle emission back to none. Again, it's going to look like that. Cycle emission back to frame. Okay, back to having the streams. So something that's cool about this is that if I go and take these particles now and put the turbulence field back on them, and then for the turbulence field, I'll just sort of get that to have a magnitude of about 5. Okay, you're going to get this. So you're going to get these sort of streamers sort of moving through that turbulence field. And this should teach you something about turbulence fields, in the sense that a turbulence field by default is not an animated field. It is a static field of turbulence that does not change. So if you want that to be animated, I actually need to go to that turbulence field and animate its phase. And so I'm just going to go to the turbulence field and write an expression on its phase so that its phase equals, let's say, time times 2. And by animating the phase of the turbulence, we're now going to actually have a moving turbulence field. And now you can see those streamers are actually sort of moving around in there. So cycle emission is a pretty trippy attribute that can be used to get some interesting effects. Okay. And so when I said it had to do with games, what I should have said back then, which I didn't, was what you can also use cycle emission for is to create looping animations or loopable animations. Because by default, when you turn cycle emission to frame, the frame value is just set to 1, which means that sort of every frame it's using this same sort of emission pattern. right? And so that's why you're getting sort of these clear streams popping up, because the particles are popping out from the emitter at the exact same location every time. But what you can then go in and do is, if you grab the emitter, you will see that where we turned on the cycle emission, underneath that you have an attribute called cycle interval, which right now is at 1. Okay? What that means is that every frame, the emitter is going to use the exact same emission random pattern. But if you put that up to, let's say, 30, that means that every 30 frames, the emitter will change its emission pattern. And so that way, if it's going to change every 30, if you just rendered out 30 frames, you could create sort of looping animations, because you know that every 30 frames, that pattern will reemerge. But at this point, if I go and hit play now, what we're going to see is this. So every 30 frames, it's changing its emission pattern, but 30 frames is a large enough number that those streams kind of go away, and it starts to look sort of more random. So the main tip for creating looping animations is your cycle emission interval. If you set that to 30 frames, what you'll probably end up doing is having the lifespan of your particles also be 30 frames, so that every 30 frames the emission pattern changes, and every 30 frames the particles die, and that'll kind of be your looping animation. So if I go in here and just grab like a very sort of simple example for that, I'm just going to go in and grab this file, and we can see this is just a generic little emitter emitting some particles into a turbulence field. But if you stare at it enough, you can kind of see where it loops, where you can see that sort of particles are sort of going through this pattern in the same way. And if I select the particles, we can see that these particles are living for 1 second. And if I select the emitter, which is in here, okay, we'll see that I've got its cycle interval. And in this file, it's actually set to 20. I should set 30. So they're at the same value. Okay, so cycle interval is at 30, and the particles live for 1 second. And so that if I go in here and hit play, okay, we can render out frames 31 to 60, and then that'll be a loopable sequence. And then that's useful for games, obviously, when you're creating loopable particle animations that can be used put on sprites, or even if you're doing web stuff and you're creating sort of particle animations to create GIF animations to put on a website. This is something that can be useful for that. We've already seen omnidirectional, so now we're going to go to volume, where it says emitter type. And I'm going to close all the folders up again. So basic emitter attributes. When you choose volume, again, you have control over your rate. You'll also see that we still have the ability to use cycle emission. But then you'll see we have scale rate by object size, which is a new checkbox that has just become usable. And that is going to do what it says, meaning that the more you scale up this volume emitter, the more particles per second will be emitted from it, which can be handy, especially when you're doing hardware or software rendering to sort of maintain the density of particles within a sort of per unit square or cubic area. So at this point, basic settings are there. Open up the next tab where we have distance direction. You'll see that the direction XYZ sliders are still active. So you can apply a directionality with volume emitters. Next folder, basic emission speed attributes. And here you'll see that we just have speed random, but speed is no longer something that will be used for volume emitters. So in making any changes to the speed setting, you won't see something happen, just speed random. And the reason is because volume emitters have their own attributes that specifically control the speed of the particles. So the next folder now, after the basic emission speed attributes folder, is volume emitter attributes, and then the next folder after that is volume speed attributes. So in volume emitter attributes, here is where you specify what type of volume you're going to create. And volume emitters basically use primitive shapes, and in here by clicking on the pop-up menu you can see you have cube, sphere, cylinder, cone, and torus. So any of those primitive shapes can emit particles where the particles are created within that shape. And so the default, and here we can see it just says sphere. Let's say I just put it to cube. Then we have volume offset, which is being used in here. And this is something that we'll see once we create the emitter, what that does. It offsets the emission of the particles from the pivot of the actual emitter. And then some other attributes that are grayed out, which are volume sweep and section radius. While if I switch to sphere, volume sweep becomes activated. If I go to cylinder, we still can use volume sweep. Cone. And then torus, we get volume sweep as well as section radius. So you can see that the attributes become highlighted or not based on what you choose, but any of these things can be changed after you create the emitter. Meaning that if I create a cube volume emitter, after it's been created, I can turn it into a sphere, I can turn it into an omni or whatever. Then we have volume speed attributes, and you'll see we've got a bunch of settings in here. Away from center, a long axis, a round axis, and whatnot. So before we sort of talk about all of these, let's just create something. And so basic emitter attributes is volume. Volume emitter attributes, I'm going to go and put it to, let's say we start with a cylinder, and I'll hit create. We see that this object pops up in the scene at the origin, which I am free to go and sort of move around and scale up if I want to. And if I look in the outliner, so I'm just going to get the outliner to pop up, you'll see that we have, like with omni and directional, an emitter node and a particle node. And the emitter, just like omni and directional, is something that can be moved around the scene, but it also can be scaled. Okay? Just be careful about non-proportionally scaling volume emitters, because they don't always give you the expected results, which we'll see in a sec. So with this cylindrical shape, if I just hit play, we can see these particles popping up. And I'm going to, as I've done before, grab these particles and change them to multi-point, just so that they're easier to see. So I'm just going to go and say multi-point, and let's maybe up the count so they're a little more visible. And there we go. Oops. There we go. All right. So we've got those particles in there that are being emitted. They still might be hard to see, so I'm actually going to do one more thing. Color accumulation is on, and I'm just going to add a opacity to them, which will get the color accumulation to be visible in hardware, which will make them a little bit brighter. And so at this point, now that I've done that, I'm going to reselect the particles. Opacity PP is in here. And for the opacity, I'm just going to throw a ramp on it so they fade out over their lifespan and have them live about 6 seconds. All right, so that's all stuff I did on the particle node. So looking in here, you can see how these particles are being emitted from that cylindrical shape. And if I select the emitter, so I'm just going to go to select emitter, grab it, open the channel box, we'll see all of our attributes. So a bunch of the attributes that we weren't able to use before are now going to make a change to how this volume emitter emits particles. So you can see that by default, the way the volume emitter is working is particles are being emitted, if you look from the top view, from in the center out. And they are emitted at any distance from the bottom to the top of that shape. If I go in here and take that volume emitter and do non-proportionally scale it so that it's narrow like this, you'll see that also is working. And so non-proportionally scaling is something that works fine for a cylinder, but you'll see that when we get to a cone emitter, it acts kind of funny. So I'm going to go and get the scale back to the default. So let's just get it back so that we're shaped this way. And let's see what some of the attributes are. Obviously, first we have rate. So if I put rate up to 500, now we've got many more particles being emitted from this thing. Okay. Then we have scale rate by object size, which is right underneath rate. Well, one thing I'm going to do is before I turn that on, I'm going to set the rate down to 1, because it requires a very low rate number is all that's needed when scale rate by object size is on. If you have your rate at 500 and you turn scale rate by object size on, you're going to get an insane number of particles. So I'm going to go and put scale rate by object size on. I'm going to hit play, and we can see just with a rate of 1, we get quite a few particles. Okay. But then what I'm going to do in here is I'm just going to put the rate to 2, so we get twice as many, still pretty thick. And then I'll take that emitter and I'll scale it down. Okay. Hit play. And you'll see that we have sort of very few particles emitting now. Scale it up. Now we've got a bunch more. Even more. Very dense. So you can see that it makes a huge difference in the amount of particles that are created. As far as its usefulness, you can see the way that it goes in and scales it isn't sort of like as intuitive as you'd think, in the sense that you scale it really big and you get a massive number of particles, which are shading, you can see if we get close, very densely. Okay. Scale that emitter down a little bit, play, wait a few seconds, and it kind of has the same density. Scale up. So it's sort of maintaining a sort of uniform density for the particles, while if I turn scale rate by object size off and put the rate back to 300, okay, when I hit play, we can take a look at our density. But now I scale it down and hit play, and you can see our density, it's a lot brighter. Scale it up even more, now it's a lot dimmer. So that's kind of like the usefulness of it, as far as being able to go and maintain the density per cubic grid unit. So I'm going to go and get the rate, leave it at that setting, scale down the emitter, and let's keep going. So now that we have this emitter with these particles coming out, there are some other attributes that we can use to modify how the particles are emitted within that shape. Specifically, you're going to need to sort of scroll down in the channel box to where we see all of our volume settings. And so you can see that right under where it says normal speed, it says volume shape, and we can see it says cylinder. And from there down, all of those basically have to do with volume emission. Okay, so you have quite a few attributes that are going to make a change. First thing, obviously, is the shape. Right now it's a cylinder. You can see that if I go all the way up here where it says emitter type, I can go and put this to an omni. So you can see that now we went from a cylindrical emitter to an omni emitter. But if I go back up there, put it back to volume, scroll down, we've got cube, and I can hit play, and we can see this cubic object emitting the particles. Okay. Cylinder, sphere, cone, and torus. And with all of these different emitter shapes, they are all emitting particles in the same way, meaning from the center out. And you'll notice if you look in here with the torus, for example, that it gives you these little arrows. And these arrows will update as you make changes to the settings to show you in what direction the particles are going to be emitted in. So going back to cylinder, just because the cylinder one can be a little bit more straightforward to understand, okay, let's start taking a look at some of the attributes. First thing is we have offset. Offset's something that I don't necessarily find to be too useful just because of the fact that you are perfectly free to move this emitter around. Meaning that if I go in and let's say take this emitter and scale it this way and set a key, and then I could go and scale it up a little bit, rotate it, and move it over there. And then if I go and play that back, you can see what's happening. So you're perfectly allowed to go and offset or animate your emitter when it's a volume, scaling or translating or rotating. But when we look at the volume offset settings, and let me just go and get rid of the keyframes that I've set on this emitter and get its scale back up to about this size so that when we hit play we're back to this point. If I go to volume offset, you'll see that you have, it's like a vector, you have volume offset X, Y, and Z. If I take volume offset X and put it to 10, that means that the emission is going to be offset 10 units in X. So you'll see the pivot point is still over here. So it's still going to rotate around that point. It's just the particles are being emitted in this location to the right. But at the same time, if I put volume offset to 0, so that things are still emitting from this point, if I hit insert, it is a regular transform node, meaning I can move its pivot point and then again rotate it like this. So I personally haven't really found a use for the offset. I'm sure there is one, but that's what it does. It's just offsetting the emission from where the actual pivot is. So again, I can go in and say volume offset Y 10 units, and now we can see the particles are going to be emitted 10 units above their default position. So I'm going to put that back down to 0, and there we go. Then underneath that, you'll see we've got volume sweep, and this is something that can be really handy. So at this point, the particles are emitting sort of in an entire cylindrical shape. But if I go and take volume sweep and change it, right now it's at 360. But you can see if I go in here and start dragging, we don't have to use the entire cylinder. We can use a half cylinder or just a portion of a cylinder. Okay. And so with that, you can see that you'd be able to do quite a few very handy different types of effects in the sense that if I went and took this, let's say, volume emitter, rotated a little bit, let's say I rotate it 90 degrees, and put it to about a sweep of 180, and also rotate it, let's say this way, about another 90 degrees. You can imagine that if you had some sort of like, cylindrical hatch that was opening up, by animating the sweep on that emitter, okay, you could sort of go from 0 to 180 to make it look like the particles are sort of emitting from an opening object. And so on top of this, if I had, let's say, some sort of NURBS cylinder in here, and for that NURBS cylinder I also go and rotate this 90 degrees, move this up here a little bit, okay. And then we go to the settings, for that cylinder, we also have sweep. Okay. And so if I go and take the sweep, we can see where it starts. So I could rotate that for my cylinder. And if I go and get it like this, I can go and modify the start sweep to change where the particles are being emitted from. So if I went and put it, to something like this, okay, and scaled it up a little bit, and grabbed the start sweep and animated it going like this, I could keyframe my cylinder. So I could say maybe set a key, and then grab the start sweep and open it, have it open up over 90 frames. And so we can see that's opening. And then at the same time, you might have this emitter doing the same kind of thing. So maybe I go to its volume sweep, put that to 0, and set a key, and then put it up to 180 at frame 90. So that at this point, we have something like that. So you could imagine some sort of hatch opening, and as the hatch opens, your particles are being distributed into the scene, okay, with this volume emitter. Okay. So let's go out, get rid of that cylinder, go back to our emitter, delete the animation on it, go back to the volume sweep up to 360. I'm going to go in here and rotate it back to its default settings. All right, back to here. So moving down, underneath volume sweep, we also have section radius. We're going to see that when we get to a torus. So what I'm going to need to do in here is go and change my emitter type now, so we can see what that's going to do. So because we know volume offset, volume sweep, okay, section radius. With a cylinder, it does nothing when I change its value. So let's switch to a torus emitter. And so I'm going to go to volume shape, choose torus, and now we can see those particles being emitted from a donut type object. And I can go and non-proportionally scale it, okay, or uniformly scale it. I'm just going to get the scale to 1, and then scale it up a little bit. Okay. Well, if I go in here with this torus, and now go to its section radius, you can see what change that makes. And so you can see this is with a section radius of 0 as it goes up to 1. So if we go and move it up to about, let's say, 0.1, that's something where we're just going to get our particles emitting sort of in this donut type shape with a large opening in the middle. And my particles are sort of living a little while, so they're kind of moving a little further, but you can see how this could be used for a variety of different effects, in the sense that maybe you have like a launch pad, and as some rockets taking off, you have this sort of torus emitter at the base that's just emitting the smoke as it's supposed to be rising in a circular shape on the ground, and stuff like that. So I can go and scale it as an object, okay, still can be rotated, and then also we can use the section radius, as well as going in here and modifying the volume sweep. So you can see that for our torus, it doesn't have to be emanating from the entire span of a 360-degree donut. So there you go. So volume sweep, section radius, and now we get into some of the more interesting ones. The ones that actually control how the particles are emitted, as opposed to just coming from the center out. So we're going to jump back to a cylinder. Hit play so that we can see the particles emitting. I'm going to just sort of move this up a little bit. And then now that we're playing, we'll take a look in the channel box. So underneath section radius, we see where it says away from center. And that right now has a value of 1, as well as away from axis, while a long axis and a round axis are at 0. I'm going to go and put away from center to 0 and away from axis to 0. And now what you'll notice is that our little sort of icon representation of how the particles were emitting has disappeared. Meaning if I put that back to 1 for away from axis, you can see the lines or the arrows appear, and then you can see them disappear. So when I now hit play, you'll see these particles have no speed. They are just being created, but they are not moving anywhere. And if I go to the speed attribute that we were using with directional and omni emitters, that's up here, I can put that to 5,000, and if I hit play, still nothing happens. So remember, that speed attribute doesn't do anything anymore. It's the away from center and along and around axis attributes that make a difference. So at this point, the particles are just sort of popping up within that shape. And when they're appearing, they're still regular particles, meaning that they could sort of be created by the emitter in this fashion, but then I could go and grab those particles and put a vortex field on them. And so that now if I hit play, we'll see how they're going to spin out. So they're spinning not because of the emitter, but because of the vortex field. And if I go and, let's say, take those particles that are being emitted and put their conserve to 0, so they don't conserve momentum, and grab that vortex field, if we now hit play, we'll see how those are sort of being emitted, where they're being emitted within the volume, emitted by the cylindrical volume emitter, but the spinning motion is actually coming from a vortex. So let me delete the vortex, grab the particles, and then I'm going to go with the particles and put their conserve back to 1. Okay. Go back to selecting the emitter, and let's look at these attributes some more. So away or along axis and away from axis, okay, we're giving us this result. And if I go in and say, or actually away from center and away from axis, at this point we've got the particles emanating this way. But if I go and put away from center off, okay, you'll see that we're still getting the same result. So away from axis is all you need to be able to get those particles to come from the center out. Okay. Then I'm going to go and put that to 0, and I'm going to put along axis to 1 and hit play. And you see, again, we get an arrow and the particles are moving up. Okay. If I put along axis to -1, now they'll move down. Okay. If I put along axis to +1 and then away from axis to -1 and hit play, the particles will go in towards the center. Okay. And again, you can see how those arrows are telling you what's going to happen there. And so now I have particles that are moving along the axis, so they're moving up, but they're also moving with a -1 away from axis, meaning they're actually moving towards the axis. Okay. Then in here, we have a round axis, which is at 0. Well, I'm going to put that to 1, put the other ones to 0, and now hit play, and you can see our new arrow. So now we're going to get particles that are going to be spinning within that volume. So they're very straightforward, these settings, as far as what they do and what you can use them for. And so what we want to do now is sort of start looking at some different examples to sort of see how these volume emitters can be used in different situations. Because they're very handy in the sense of having very precise control of where the particles get created in the scene. So I'm just going to make a new file. And the first thing I'll open will be an example of a cube emitter. And so I'm just going to go in here and grab this file. Okay. And so what we'll see in here is that I've just got this grate. And with the grate, we can see that if I just sort of jump to wireframe mode, and right now we've got a cache that's being used, which I'm going to turn off so that we can tumble again. And in the scene, we can see I've got this little volume emitter right there. And it's a little cube volume emitter. And I have some keyframes on that cube volume emitter, so it sort of animates and moves into the scene, because what I wanted here was to get some steam to be rising out of this grate. And so if we go in here now and hit play, okay, we can see how steam sort of begins to rise. And if we go in wireframe mode, you can see how that volume emitter just sort of moves into the scene. And the only reason I did that was basically so that it doesn't look like the steam rises uniformly from the grate, but it sort of starts on the right and moves in from the right to the left by just animating that volume. And then the nice thing about having that cube volume emitter is the fact that it actually matches the shape of my grate. And so that you perfectly know by grabbing this emitter right here where your particles are going to be in the scene. And so it can be very handy that way. And so if we go in and play it for a few frames, you'll see that I also have some more cubes in here. Those are not volume emitters, those are just volume fields, turbulence and uniform. So that I have fields that are just existing within a very specific place in the scene. And so you can see how due to the turbulence and the uniform field, those particles are sort of moving out from the grate, moving up, having a little bit of turbulence. And then if I just jump to the hardware render buffer, you can see if I just render it with a few passes, that you get some nice looking steam coming out of there. And so, not sure if I actually have a QuickTime movie of that. I think I might. Here we go. Just so that we can see it playing back. And we can see that steam coming out of there. So just simple hardware rendered steam using a volume cube emitter with a few render passes so they get nice and blurred. And so there you go. Straightforward example, but it sort of shows the clear benefit of a volume emitter as opposed to omni or directional. Meaning that if you wanted particles to be emanating from that grate, omni or directional really wouldn't get you there. Okay? In the sense that these particles are all sort of moving in a straight up fashion as if the emitter was a lot further down. If you wanted to do this kind of thing with the directional emitter, the emitter would need to be very, very far down so that by the time the particles get to the opening of the grate, they actually are moving almost parallel to each other. Okay. We can now look at another example. The next example that I'll show will be an example of a sphere emitter. And so I'm just going to go in, find that file, which is going to be in here somewhere, which is, here we go. And so what I've got here is I basically just wanted to take a sphere and sort of have like a glass orb or a glass sphere filled with smoke. And so this is something that kind of required combining some hardware rendered particles with some software rendered geometry so we could have the sort of reflecting surface with some hardware rendered smoke on the inside. But when we go in here at play, you'll see that it takes for the first 50 frames it loads those sprites in, because I have sprite particles. And when we go and hit play for a few frames, you can see what this is looking like. And I can go and tumble in this scene. We can see those particles, so it's kind of like I've got some smoke just sort of emitting within this orb. But the way that I did this was by using a volume emitter. And so if I go in here, we can see I've got a spherical volume emitter right there that's emitting particles going along its axis, or around the axis. You can see that round axis right there, as well as a little bit of a long axis. And so those particles are spinning around due to that. And then if we go and look at a rendering of that, which I closed my QuickTime movie window, so let me just get that back. And let's just sort of resize this, jump back to Maya, jump back to the QuickTime window, and play this little movie. So you can see that we've got software rendered ground, software rendered ray trace shadow, software rendered, reflecting geometry. And then when I hit play, we have got hardware rendered smoke that's inside there, just by rendering things in passes. So that I render the background, then I render the smoke with hardware, and then I render the reflection map on top of that separately, and then combine it all together in post. And you get your little hardware rendered smoke. A couple of the issues that came into play when I set this file up, though, however, that you have to be aware of, is that if I go and for now, let's just sort of delete that sphere, and I'm just going to delete something that's in the scene. This is just my volume emitter. But when I hit play, what we're going to see in here is that my smoke is going to sort of start going all over the place. And in the sense that it's sort of going to start escaping from my sphere, it's not going to stay within the orb. And that's going to become more pronounced if I maybe grab my turbulence field and get that to be a lot stronger. And with a stronger turbulence field, now it'll become a little bit more evident that those particles are going to start to move around. Although I think I have another field in here other than that, which is sort of affecting them a little bit more. And so I'm just going to go and put that up and grab that field and put that up as well. And for the particles, let's go and make a change there. That's okay. And so they're kind of able to sort of go wherever. But what's going to be easier to show this, to be honest, is to make a new scene and to create an emitter. Okay. Specifically, I'll create a volume emitter, sphere. Okay. Move this up, play. Okay. And we can see how those particles are exiting the volume. Okay. Well, with that glass orb, what I needed to do, if we go and look at that QuickTime movie again, so of course I keep closing this window, but I'm just going to go in, smoky orb, it's very important, obviously, that it stays within the glass, right? That it does not escape there at all. And so to do that, if you just have a volume emitter, you can see that they can very easily escape. They don't stay in. Well, one thing that you can do is if you select the particles and go to the attribute editor, you'll see that there is an attribute on the particles within the emission attributes folder, which is called die on emission volume exit. And if I check that and hit play, we'll see this. The moment the particles exit the volume, they die. And so that can be handy, but the problem is they're literally just going to pop up. They're just going to disappear immediately. And that's not something that you necessarily want if you're doing something like smoke. So the workaround for that is instead of using that attribute, I'm going to turn that off so that they do exit. What you want to do is select your particles and then apply a field to them, specifically a radial field, where for the field I give it a volume. So I'm going to make this have a sphere shape for the radial field, and I'm going to turn on volume exclusion, which means that the field will only exist outside of that shape. And I'll give it a, let's say, -20 magnitude, and now I'll hit play. And you'll see that. The moment those particles touch that radial field, they get pushed back in. And so it's kind of used as a force field to keep them within the volume. So if I give it like a -1, okay, you'll see it's a lot more gradual. So they don't immediately change direction. And so this might be kind of difficult to see on the TV. So let's go in here and switch to multi-point. Okay. Turn on color accumulation. Okay. Turn on opacity. Get these particles to fade out with their lifespan. Get them to live maybe about 4 seconds. And then in here, let's go for those particles and maybe up the count and the radius a little bit. And then for my emitter, I will up the amount of particles that it's emitting up to 500, and now hit play. Okay. And we'll see this. And so we can see that the particles are being emitted within that volume, but then the radial field is keeping them inside, so they don't exit. So that was a workaround so that you don't have to use that die on volume emission exit. So this way they just sort of stay in by bouncing. Because I can go to that volume emitter and say maybe they move around the axis as well. And when I hit play, now they'll be spinning, but they're still staying inside there. Okay. And let's go and up the rate even higher so that it's even clearer or easier to see with those particles. So they're staying inside the volume. Okay. So another example that I'm going to show is an example of using, let's say, cylindrical emitters. And so I'll start by just going and grabbing, let's say, this file. Okay. Just a simple rocket. And so when I go in here and I hit play, what we're seeing is just this sort of rocket whizzing by the camera with some particles that are set to be rendered to cloud mode. And so if I go and look at the actual rendering of that, okay, we'll see we've got some software rendered smoke coming out of that rocket, which is motion blurred as it flies by. And since it's software rendered smoke, we're getting shadows on the ground being cast by the smoke, which is cool. But the way I decided to do the emission of the particles in here was to go in, if we hit play for a few frames, let me now grab this rocket, okay, and take a look at it, not the particles, but the rocket itself. Okay. And you'll see that I very simply have, if we zoom in here, a cylindrical emitter. So let me just go and grab that. And there it is. So that right there is a cylindrical emitter, which is emitting the particles out from the end of that rocket. Because the thing is, I didn't want to use directional because I didn't want the particles to be coming out from a simple little point. Okay. And so this way, by using this cylinder, I was able to get the particles to come in or be emitted from the rocket as if they were being emitted from a larger area as opposed to a little tiny point. And so that way, if I go in here, we just go and switch to a different camera. And let me go and just sort of zoom in on that. We can see how those particles get emitted from that shape. So obviously this guy's moving pretty quick, but if I go and grab this, I could delete the animation on it. So let's say delete selected, hit play, and we can see how those particles are being emitted from the end of that rocket, just from that cylindrical emitter. Another example that I'll show is another example of a cylindrical emitter, which is relatively straightforward, okay, which is going to be this one, which if I can go in and actually reopen this scene, okay, where we just have a pretty generic looking little warp drive thing going on. And if we look at a rendering of that, we just see again these are hardware rendered, and so they have a little bit of motion blur on them and whatnot. But the way this is accomplished is again just using a cylindrical volume emitter. And so there we have our emitter, and if I hit play, okay, we can see how those are being emitted out from that volume. And actually in here I think that there is, let's go and switch out of here, if I can find a different one. Here's the one that I showed from the rendering. So you can see those particles coming out there. And the thing that I wanted to do with this is that once you sort of like move into the warp drive, you see how the particles, they kind of like fade on at any location. But then once you get to around frame 80, they're only being emitted from down here. And so the reason that's working is because you can see if you look at the volume emitter, if I grab that right there, you'll see I've animated it scaling down. Okay. And so that at frame 1, it's kind of large, so the particles sort of fade in at any location in here. But then once a few frames passed, now that volume emitter is just over here. Actually, let's get that back on. So that the particles are just being born in this location. And so you can see in here, if we go and fly through this, okay, from any location or angle, all I need to do now is just jump to the hardware render buffer, okay, and we can see how things get sort of smoothed out in there. And if I go to the render attributes, I'll just go and turn off our blur there, okay, and we can see our little streaks coming out that are nice and feathered and blurred. Okay. But they're just coming out from a simple volume emitter. Another example I'm going to show is, let me just jump onto this area. And this is just sort of like a software rendered example of some clouds. I showed this earlier, this file. Okay. And so as far as the QuickTime movie goes, I think it was this one. And so the clouds that are up here, I use the particle tool to place into the scene. But the particles right here that we see in this little sort of smoke column, that we can see sort of like in the back of the frame, and maybe if I sort of switch to a full screen mode, it's a little clearer what I'm talking about. Those are also coming from a cylindrical volume emitter that I placed on the ground back there. So if we look in the scene, if I close this file, and we jump in here, if I just go and let's say hit play for a few frames, and just sort of switch to a wireframe mode, we can see we're going to sort of move through as the camera's animated. We can see those particles back there. Okay. And so we're just moving through, but now I'm just going to go and grab the emitter, select that emitter, and let's now go back into shaded mode. And we can see that we just have the cylindrical emitter. So again, anytime you have an opening, whether it's a cube or a cylinder or whatever, like a grate like I showed earlier, or a rocket, or this where I just need this hole in the ground to be emitting smoke, cylinders can be very, very handy just to get those particles into the scene. And if I just jump to a different camera, we can see how those particles are just coming out of that emitter. So there you go, another simple example. And let's see what else. Some other things, if I go, let's go and jump over here to this little smoke tunnel looking thing, which I think is in here somewhere. There we go. When I hit play in here, it's sort of another cylinder, okay, emitting particles, which are sprite particles, as we can see. Okay. And so they don't necessarily look all that exciting right now, but if you're just having to do some big animated column of smoke, okay, you can see once rendered, with a little bit of motion blur, you can get some pretty interesting looking results. And this is just hardware motion blur. And so these render really, really quickly. So if we're doing like huge columns or vortexes of smoke or different types of particle effects, you can see the very nice results that we're getting with the hardware rendering, but also the simple emission just using a cylindrical emitter. Same thing going on with this one, just sort of different colors, but you get the same idea of how that volume emitter will look as far as how its particles are being created. Okay. So jumping back, another example now that I'm going to show, a couple more, is let's go into here, and what we've got going on, if I select the particles, are some simple bubbles. And so these are just some bubbles in a glass where if I go and let's say hide the geometry, again we have a volume emitter. And so we will notice that I've got to pick them so you can see them just because they're blobbies, so that's how they'll render. And you can see they're moving up inside that cylindrical volume emitter. Each one gets a different radius just using a creation expression on the radius of those particles. And then you'll see how when they get to the top of the liquid, they stop, live for a couple seconds, and then sort of pop and die out when they get to the top of the liquid. But the emission is just a simple volume emitter again. And so if I get the geometry back, we can see those particles just existing within that glass. And then if we go in and go to the render window. Let's see if I've got a image, and there you go. And you can just see the little bubbles in there that are blobbies, meaning that they can be ray traced, so they can reflect and refract, all that kind of stuff. And we can see the little bubbles inside the glass. Okay. But another straightforward use of a cylindrical volume emitter. And then finally, the last thing that I'm going to show is an example where I used a cylindrical volume emitter one more time, but this time just to do some smoke coming off some tires. And so let's get this scene opened. Give it a couple seconds to load. And let's go and you can hide the channel box. And let's get the time slider, the range slider. So if I hit play in here, first let me just show a movie of this, some tire smoke. And so what we can see is as a car sort of races off, you get all this smoke coming from the tires. I'm just going to go up to a full screen mode so we can see that again. It's a little dark, but sort of get the idea. Okay. So relatively straightforward, simple example, and that smoke eventually, as it's sort of moving by, just sort of dissipates. And this is all hardware rendered, and so we don't have any shadows or anything being cast at this point. But the way this is working, if we look at the scene, is as this vehicle is sort of moving by the camera, and it goes slow for the first few frames because it's loading the sprites in, and once the sprites are loaded, things play back faster, which is normal sprite behavior. But if you take a look on this vehicle, if I select the emitters, there we go. So I've got some cylindrical emitters where their radius is only set to about 30 degrees, and then you can see that I just have those parented to the car, or to the vehicle, underneath the tires. And so as that car is moving forward, we can see how that smoke then gets emitted from that location. So a really handy little use of getting those particles to pop up in the scene exactly where I need them, again by using a volume emitter. So at this point, I've pretty much talked about the basics of some general emission stuff, rules, which are very, very important, which you're going to be using all the time, specifically omnidirectional and volume.
We hope this DVD has helped you learn more about Maya, and we appreciate your support. Visit the normanworkshop.com or visit norman3d.com. For training, visit Norman Online. DVDs by Dave Michuda.